Thank you for that lovely introduction. Thank you to the OACETT committee as well for selecting my project. It's an honor to do a presentation in front of everyone here. So I'm here to talk about the intelligent rail systems solution that was developed over the last 4 years at Hatch. And things that you will discover during this presentation is the creation or the use of automation tools will definitely reduce design times required for our detailed designs in rail systems. Project collaboration tools will enable standardization and it will create project efficiencies. And information modeling, and most people call it BIM, I prefer just calling it information modeling. It will definitely bring new opportunities to the rail systems group at Hatch. So to give you a bit of an overview of our current CAD system, we use 150% design templates because our designs are very modular. So we remove redundant information and apply site-specific information to design sets. The process is time-consuming, tedious, and there are many mistakes a designer can make during that repetitive process. There's no intelligence, there's no connection to the bill of material, there's no model, and there's a huge frustration between designers and senior checkers as there's a continuous back and forth between them. So when coming up with a new design methodology, our rail systems group utilized the principles of building information modeling. But we really wanted to address 6 main goals for our industry. That was an automated bill of material, 3D visualization to eliminate installation conflicts, enhancements of wall layouts, so this was wall layouts with a 2D underlay effect, which is a rail system standard and mandatory amongst all the railroads when doing designs. An automated wire schedule, template modification, so this is replacing that 150% design template with an automated process. And of course, we need to eliminate designer-based errors and eliminate that repetitiveness that no one likes doing as they enter 7,200 data entries. But we really tested 3 different solutions. One solution came out on top and achieved all 6 goals. So a business case was put forward in a project plan. Once that was submitted and approved by management, it really was the birth of our intelligent rail systems design solution. So what is it? It basically introduces intelligence into CAD. So every component is holding asset information. You have asset tags, installation location information, manufacturers, part numbers, and we can run an automated bill of material with that information. It has a single database, and working in rail systems, this is our greatest challenge because we're a niche market and everything basically has to be tailored to suit our industry. Our industry shows everything differently and our industry is very unique and small. So it had to be able to be customized for multiple clients, and we're sharing one database and every client wants to show things in a different way, and that's my greatest challenge moving this forward. And it builds a relationship of the 2D schematics, which are a requirement in any electrical or rail systems design, with the model. And that database really controls that relationship between different modes of a particular component. So when we look at project collaboration, this is sort of a window of project collaboration using the system that has been created from a rail systems designer perspective. So the promisee users are the rail systems designers, and they're all pointing to that centralized data. They're all pulling from it, and when it's updated, it's updated instantly. Everyone gets that information because it's on a shared network. That database is communicating with a SQL server to pass and store information on projects. And in this scenario, we're using ProjectWise as drawing collaboration. We do use ProjectWise for more than just drawing collaboration, but for simplicity purposes, I'm just mentioning drawing collaboration in this scenario. Now, when we look at our assets and we can control where they're being shown in different mode functionalities, there's a navigation flow associated with the system. So I'm going to pick out a relay and explain the operation of navigating through a design. And anyone who's electrical will say that's not a contact, but that's the way we show contacts in the rail systems industry. So it's not normally open, normally closed. What we're doing is we have a front up, front down contact that will, on the heel, will go up and down, depending whether or not the coil is energized. But that has a direct relationship with that coil symbol, which has a direct relationship with that 2D schematic layout, which is directly related to the 3D model. And because I did things in a 3D model, I can make these pretty pictures. But what I want to do in this presentation is give you a feel of what it feels like sitting at my desk. So here's a UI video. This is a contact, and I'm going to right-click on it and navigate to its parent, which is the coil symbol. You can see there's a relationship there. It highlights it. I'm going to right-click, navigate to the layout. I want to see where this is in the layout. So we'll go to the layout drawing, zoom in, show me where the relay is. 2D schematic level to meet the rail systems industry. Let's see what it looks like in 3D. Let's see how that relay is mounted on the relay rack. Let's open up those visualization tools, take a snapshot, and send it to the client. So when it's set up, that relationship of that asset across the design set, you see huge benefit. And you can't over-assign a contact because it won't let you. And when we define our asset tagging, this is really another thing that is unique with the rail systems industry. We don't define our assets by schematics, so we don't follow the IEEE IEC standards. We define our assets by where equipment is placed on the wall. So we developed a custom grid system which define the assets automatically based on wall placement. So what does it look like in the UI when you operate and model? Well, this is the schematic representation of a tip 2 panel. It has an abbreviation of SUCE 46, SU specific for that tip 2 panel. CE is saying it's on wall C, region E, and it's 46 inches from the left side of the wall. So when a designer wants to move a particular piece of equipment, he simply selects the equipment in that 3D layout. And what you can do is you're going to see that asset tag change automatically here. So I'm moving it 10 inches to the right, so it should change to 56. And as I view that device ID, you can see it's done so. So that's some hidden information in that layout. But I want to see if it changed on the schematic. So let's navigate back to the schematic. And you can really see that because you have that relationship of that component, that update is done automatically. And it's something you don't need to worry about. Wire tagging is huge in our industry. So I'm going to point out 3 pieces of equipment. And these 3 pieces of equipment alone, in a 4-track intermediate design, using the intelligent tagging system within the system, you eliminate 7,200 potential data entries of just one design, and you could have 40 intermediate designs on a particular project. So this is data entry no one likes doing, and we need to eliminate it. And this is a process that can definitely be done, because we're taking information from the schematics, and we need to apply it, that tag, in another form on a different sheet. So a WAGO terminal, people are probably familiar with WAGO terminals. A geo module is basically a PLC module. A geo module is specific for a Siemens card, and it's got its own logic controller specific for rail systems. And an entrance board is essentially the separation of dirty and clean wires. So all your field wires come into the entrance board. They are grounded and protected by arresters. But I'm gonna show you the geo configuration chart. So this is the geo configuration chart, and you'll see a lot of sheet 6 references. So that's where that particular component is shown in the schematics. But I want to change that sheet 6 to 26. I'm going to just open up the project manager, change the sheet 6 to 26. What you're not seeing here is it's changing the DGN name automatically. It's changing all the information on that title block automatically, so you don't need to worry about it. But as I go back to that geo configuration chart, you can see that the 6s turned to 26s and I didn't do a thing. Let's go to the top and we're going to go to J4-10. We're going to navigate right to that particular input. It has a wire tag of 1TAL, I believe. Yes. I'm going to change that wire tag, and I'm going to change it for this presentation to my last name. I'm just going to call it Henderson. But when I update that tag through that wiring manager, it's updating that data across the project. So anything that's referencing that particular tag will update on other sheets. As I navigate back to that geo configuration sheet, it does preload all the data and update it when you open that drawing. So there's a little bit of a pause here, but you can see that that tag changes by itself. This is information that no longer has to be inputted. You put it there and you forget about it. Additionally, we had to create our own track layout mode. It's just another mode that was required specific for our industry because we show in schematic representation equipment in the field. So signal masts, signals, switch machines, snow melters, bungalows, everything that's situated outside of that bungalow is shown in a schematic representation, and it needed another mode functionality, and we directly relate that to the layout deliverable. The layout deliverable is directly related to the 3D model. So all the user really has to do is the annotation on top of the model. That's basically the designer's responsibility. But that can be done automatically through automation, and I'll show you a little bit about that. Let's talk about project automation. So we developed our own custom front-end wizard, which basically is a series of drop-down menus, data entries, selection boxes. What this does is a designer will read a route and aspect, put in site-specific design variables, and output a spreadsheet, which is then passed to that Promisee API. So what happens when you pass that spreadsheet to the API? Well, this is what happens. Now keep in mind the bottom right corner, the time is 11:23 a.m. This video is increased in speed because I am limited to time during this presentation. But what you're witnessing here is an intelligent project being created, intelligent title blocks being applied, their associated attributes being filled based on those user selections on that front-end wizard. You're seeing schematics being generated. These are schematics that have asset tagging information, so after the automation of the project is done, you can do an automated bill of material and an automated cost estimate. We're doing wire tagging. We're customizing our wire tagging again based on those user selections. We're re-tagging wires, selecting gauges. This is all possible depending on the variables you put in. So we're automating our wire report generation. We're creating layouts that have that 2D schematic underlay effect, and they have that 3D model. This is all done automatically, an intelligent project with a 3D model with a direct relationship of model components and schematic components. And what you're seeing here and what you're witnessing here is really a 31-page project being completed and an intelligent project being completed. And the time at the bottom as it comes up is going to be 11:28 a.m. So that's a grand total of 5 minutes. I've also done 13 designs and left for lunch and came back with 250 drawings done. So anything is really possible if you put that front-end effort. So why information modeling? Why bother? You get a lot of constraint from people in electrical or rail systems, but collaboration. Rail systems currently, I can do 6,000 drawings and not have a conversation with anyone in civil. It's sort of a process that Carl and I want to eliminate, and Carl is here. There's huge potential with mobile applications and geospatial information, and I can probably do a presentation just on this, but there's huge potential moving forward with information modeling and in mobile applications. And then we are now going into some point cloud surveys. We are even putting them in our proposals, doing drone surveys, so we can pull that data and share it with our clients. I'd much rather have a drone survey than someone's field markups, that's for sure. An asset lifecycle. Why aren't we putting in the planning and design phase associated with that asset lifecycle? In North America, I don't know why owner and operators don't demand this, because it's something that is a requirement in Europe. And 3D PDF, so this is a 3D PDF. It's just using Adobe Reader. But the last sheet, I just threw the model in the plan set. So and I put in some save views. So really anyone can just look at the model quickly. You can see what clashes are there. You don't need additional software. It's just a reader. It's quite easy to use. You can even put in buttons and control views that way if someone gets confused with the top tools. And making pretty pictures. This is a huge marketing aspect associated with this. It's great seeing your designs before they're in place. I personally get more excited about intelligent schematics, but I do understand why people get excited about the renders. And moving forward and continuing to move forward, we see this as a competitive advantage. And where exactly is it? Well, the quality of the systems. The quality of the system can't be matched using any other standard in the rail systems industry today. The flexibility where we're able to react to design and scope changes to relative ease, update reports in a matter of seconds, and that interdisciplinary opportunity or opportunity because this is opening up potentials of rail systems finally collaborating work with civil. And this has really been an award-winning, globally recognized result, winning for innovation in rail and transit at the Be Inspired Awards in London, England. It also won Hatch Global's Steve Lawrence Design Excellence Award, which recognizes the use of innovative technologies and methodologies to solve a complex design problem. I've been a speaker at many events across North America and in the United Kingdom. I've also done global webinars for Pacific countries as well, relating to this particular subject. So what's next? Who cares about the awards you won in the past, right? That's the past. How do you continue to push the envelope? How do you continue to innovate? Because the moment you stop is the moment someone passes you. And that's more collaboration. This is bringing in track alignment and constraining equipment to track alignment and making that a dynamic atmosphere. We're not there yet, but we're going to be there. Train simulations while you're doing your designs. This is a visualization simulation. And basically, we can wrap this model with imagery and you'll get a realistic representation of that simulation. And this is a mandatory requirement in the United Kingdom where all signaling equipment has to be approved by a signal sighting chair. Signal sighting plans have to be developed. So it's mandatory in other countries. And asset performance, working at a consultant firm, I really don't have any assets to maintain. But what this is doing is it's opening up new opportunity. Perhaps we can do asset management on behalf of a client. So in summary, we've realized we can cut costs through automation. We can enable standardization through project collaboration. And we definitely can create new opportunities with information modeling.